Bonjour and good afternoon. Welcome to WASA Distance Education Center and PLAR Science. So we're into the third class for this week. The third class for Term 2B, and this is our second class for the week, so it's still week 2. Today is Wednesday, April 24th. So we're almost getting close to the end of April. Just to point out again to the students that if you are submitting work or if you are completing work, that means receiving a credit, then your name will be going into the Term 2B draws. We've already had Term 2A draws. We had 2 students, one who completed or was granted a credit. That person received a Dell laptop, and then another student who have been submitting work, her name was drawn from all the names for students that completed work for Term 2A, and she won a mini iPad. So we'll keep you up to date on what the prizes will be for this term, which is Term 2B. So again, if you submit your work to your teacher, that will be entered into the draw, or if you complete a course. So that means students working on more than one course will have their names entered for each subject that they submit work for. Students can still register for independent learning or IL courses at any time during the school year. However, you must complete the course on or before June 13th. Students can expect regular contacts by phone, by email, or if you have Facebook or another type of social media, you might have, that's if you submit that to us, then your teacher will contact you through there. And again, speaking of contact, if you wish to get a hold of me for PLAR Science, PLAR History, PLAR Geography, you can call me at the office at the 1-800-667-3703. That's the toll-free number. My extension is 2204. You can email me at jmercer@nnec.on.ca. I have Facebook, or my work Facebook. You can message me there at jmercerwasa if you have problems with your course assignments or key questions. And my office hours schedule is available from your DEC, and you may also call me at home. So lots of ways for you to get a hold of me so that you can complete your work for this term. There are several options for you to submit your key questions. You can have your DEC fax them for you. She or he can scan email to studentwork@nnec.on.ca. Make sure you CC the teacher that's marking your work so that we are aware that you have submitted something. You can use your Notes app to scan email as well. You can send a picture through Messenger, or another option is if you scan the pages. There's also an outdoor mailbox. If you're here in Sioux Lookout, there's an outdoor mailbox on the side of the WASA building. Just make sure that you put your name on your work, or you can go to the front door. So we're right by the post office. Just knock on the door and someone will let you in. Students are also encouraged to watch the classes. So if you can't make it for the radio Zoom tutorials, you can go to YouTube. You can watch classes under playlists. So there are playlists for PLAR History, PLAR Geography, and PLAR Science. If you're working ahead, you can you can view the PLAR Science 1B playlist. But if you're still working on Lesson 1, you can go to the PLAR Science 2B, so all the classes that I'm doing for this term will be uploaded on that playlist. If you're working on your PLAR History, go to the PLAR History 2A playlist, or if you're working on your PLAR Geography, you can go to the PLAR Geography 2A playlist. If that doesn't work for you, you can ask for a USB of classes. So let's say you have problems getting on your internet, or you don't have internet, or you don't have access to Wi-Fi. We can download the classes on a flash drive. These can be viewed on your laptop, your television, your Xbox, or PlayStation. So as long as you have a USB port to insert the flash drive, then you can use that. When you insert that in there, you will see that in order for you to open the lesson, you have to choose which key question or key questions you might be interested in watching. So let's say for PLAR Science, you might be interested in key question 32. You would go to PLAR Science, so that's the name of the course, lesson 2. So which lesson? There are 5 lessons for PLAR Science. So lesson 2, and then it says key questions 31 to 35. So that's the class that you would watch, because in there key question 32 will be in that class. Okay, so it's organized that way so that you don't try to download or try to click on the class and you're not sure which key questions are in that class. Same thing for if you're using YouTube to watch the classes. It will the drop down menu will look like this. So it will show you which lesson, which key questions are within the class. Alright, so we're still in week 2, and we are still working on lesson 1, astronomy. I'm not sure if we'll finish all of lesson 1 for this class, but let's see how it goes. Remember that you have to attempt the key questions in each lesson. There are 80 of them, so key questions 1 to 80 of lessons 1 to 5. Once you complete that, then depending on how you do with the lessons, then you will be either eligible, or you might be asked to redo some of the key questions or resubmit. If you are successful in doing the key questions, I will either send it to the DEC or to you. The culminating activity, you need 50% to pass the culminating activity. Once you pass it, then the equivalent credit will be granted to you. And that means that your transcript will be updated. If you have previous versions of lesson 1, so that means if you don't have the 2023-24, or let's say you were working on some key questions from last year's version, instead of redoing or starting over, let's say you completed lessons 1 to 2 key questions from last year, I will accept work that's been submitted from the previous format or version. Okay, and if you're not sure, just ask me. Let me know how many key questions you have completed from a previous version. So as you can see, there are 26 key questions for lesson 1. So again, these questions will be used by me to assess your achievement of each lesson's expectations. So you have to answer the key questions for each lesson and submit it to me or to your DEC. This will let me know how well you have understood the ideas or concepts within that lesson. So again, I'm trying to prepare you to do the culminating activity. So we have so far completed key questions 1 to 12 already for lesson 1. So again, this mark sheet, it gives you an idea or It shows you as a checklist which key questions you have completed. If at any point you submit a key question and you want to resubmit it, or you misunderstood the question, you can resubmit it as many times as you want. So for this afternoon, we have page 32. That was what we talked about on Monday, the moon as the Earth satellite. So we will continue with page 34. Does the moon have gravity? Page 34, phases of the moon, or not F-A-C-E-S, but face, F-H-A-S-E-S. Page 37, space exploration. Page 38, what are satellites and space probes? And page 40, human space exploration. Okay, we might get as far as that. I think that's probably how far we will get to this afternoon. So learning goals, I will understand the challenges and benefits of human space exploration. Okay, so again, this is on page 34. Does the moon have gravity? First of all, the word gravity means it's a force that attracts objects together. So on Earth, this force attracts everything to Earth. So no matter where you are on Earth, all objects fall to the ground. And you might try it. You throw a pencil in the air, that pencil will fall to the ground, okay, because it has gravity. You can walk on the moon. And we've seen astronauts walking on the moon because the moon has gravity. Its gravity will pull on you, so you won't fly off into space. However, as you walk on the moon, you'll feel lighter. And the reason for that is because the moon's gravity is weaker than Earth's. The moon has no atmosphere because its gravity is so weak that it cannot hold an atmosphere around the moon. So as you can see, the Earth is larger than the moon, so it's a large object. It's also very heavy. This means that it has a strong gravitational field. So because the moon is smaller than the Earth, then that means it's not as heavy. So even though the moon's gravity is weak, it still pulls on the Earth. So for example, it pulls on the Earth's oceans, causing them to shift regularly. So we talked about that on Monday. That's known as the tides coming in and out. So we said on Monday that the moon is responsible for the tides. Okay, because it causes, because it pulls on the Earth, and it affects the Earth's oceans, causing them to shift. Okay, phases of the moon. So the moon doesn't have a light of its own. We see it shining at night because it reflects the light from the sun. Remember, we said that the moon is non-luminous. So the half of the moon turned towards the sun is always lit up. However, on different nights, we see different portions of the moon shining. And this happens because the moon is rotating around the Earth. So parts of the moon that we see shining is called a phase of the moon. So I don't know if you saw last night, we had a full moon. So the moon reflects the sun's light. and so its shape changes along with its position relative to the sun and earth. So if you look at the moon phases, you can see here, so you can see the earth, it's right in the middle, and then see the person right there. There's the sun right here. Okay, the moon. Okay, so I'll play that again. You can see that it's rotating around the earth, so we only see bits and parts of it. So sometimes it's lit, sometimes it's not. Okay, so why does the moon appear to change its shape at different times in the month? So we're going to look at the moon phases, different ones, the first quarter, the waxing gibbous full moon, so that was last night, waning gibbous third quarter, waning crescent, and the new moon. So you can see the different positions of it relative to the sun and earth. So another way the moon moves, the same side of the moon always faces earth. So why do you think this happens? Well, if you put a chair in the middle of a room and you face the front of your body to the chair, try to walk slowly around that chair. So as you walk, keep the front of your body facing the chair. That means you don't turn around. So it's kind of like musical chairs if you want to make sure that you don't lose your spot. So what do you have to do to your body so that it always faces the chair? It means that you have to keep turning your body so that's always facing the chair. Okay, you have to rotate it. Okay, you don't turn away from it, but you rotate it. Okay, so think about the moon. So what does it do? Well, what it does is it rotates. It's doing the same thing. So the moon orbits Earth every 27.3 days. As it revolves, it also rotates on its axis. Notice on the bottom here, so as it's rotating, that's what we're seeing. So the different phases of the moon. Okay, that's why the same side of the moon faces Earth at all times. So now you can see at the bottom, this is the side that we can't see. And then this is the side that we can see. Okay, in your book you will see support question number 2. You do not have to submit that for marking. You have to fill in the chart by listing the names of the other 6 planets in the order of their location to the sun. The first and last planet have been done for you. So the first, which is closest to the sun, is Mercury. The farthest from the sun is Neptune. So you have to fill in second, third, fourth, fifth, the 6th, and the 7th. So if you have if you had developed a mnemonic or a clue for you to remember it, then you should have you shouldn't have any problems. So if you remembered, my very eager mother just served us, in nachos. So now you know that V stands for Venus, E for Earth, M for Mars, J for Jupiter, S for Saturn, and U for Uranus, and then you have the 8th planet, which is Neptune. Second question for the support question is the core of the sun has a special type of reaction going on. What type of reaction is it? Is it called A, chemical fission, B, chemical fusion, C, nuclear fission, or D, nuclear fusion? What is the core of the sun producing? Is it A, copper, B, hydrogen, C, oxygen, or D, helium? So you could try these out again. These are support questions, which means that the answers are at the end of your lesson. So you could try those out just for practice. Okay, next up is our key question. So from our last class, we completed sorry, not that one. We completed key question 17, identify at least 3 differences between the inner planets and the outer planets. So that's pretty straightforward. You tell me what are the difference between inner planets and outer planets. So for example, inner planets are smaller and made of rocky materials. So how is that different from the outer planets? Well, outer planets are bigger and they're gaseous. That means it's made of gases. Key question 18, explain why the moon has no atmosphere. So you start off with the moon does not have atmosphere because, so we just went over that. Key question 19, why does the moon appear to change its shape? The moon appears to change its shape because, okay, so just make sure you read the section that we just went over. Key question 20, it says complete the following table by filling in the required information. Now notice the first one has been completed for you. So the first column says name, so that's the planet chart, which means you put in the names of the planets on this column, starting with Mercury, so make sure this is in order. Okay, so you would fill in the name of each planet. The second column asks whether it's terrestrial or gas giant. So in this example, Mercury is the first planet and it's a terrestrial planet. Number of moons, okay, Mercury doesn't have any moons, so you would write 0. Rings, does it have rings? You either respond yes or no, in this case no. And the visiting spacecraft, this one says Mariner 10, so which means that you have to go back to the section, so you have to read each planet's information, and you would have to look for the information there. Again, this is a hand question, which means that you can find the answer, or you could put your hand on the answer. So number 3 on that planet chart is Earth. And I'll just do this one as sometimes there's some sort of confusion with the visiting spacecraft. Okay, so the third planet is Earth. Is it a gas giant or terrestrial? Well, we know it's terrestrial. Number of moons. Okay, we have 1 moon. Rings, no. Visiting spacecraft, you can put not applicable. Okay, we are usually the ones who send the spacecraft into space. Okay, it's not visiting, it's there. So you can put no, or you could leave it. Okay, next up is space exploration. So scientists do more than study space. Okay, the other thing that they do is they send things and people into space. In 1957, the Soviet Union launched the first artificial satellite called Sputnik into orbit. Since that time, the United States, Soviet Union, and other countries have launched things into orbit around the Earth. There are a number of reasons to put people and satellites into orbit. Okay, so again, keep in mind, why are we exploring space? Well, one of the reasons is because it's there. Quest for knowledge, we want to learn about what is around us. Could be we want to learn about it for its benefits, so it might be useful for us. We also might want to learn about it in case it's not beneficial to us. There might be dangers or concerns about what is around us. Okay, reap benefits of what's around, reap benefits of preparing for or undertaking exploration itself. For example, technology and techniques. Also for survival. What if something happened or happening to Earth that we might need to explore other places to live? And also a quest for understanding, meaning we have to learn about ourselves and our place in the universe. So lots of reasons why there's space exploration. Okay, page 37. What are satellites and space probes? So a satellite is something that orbits another object in space. So we said that the moon is a satellite of the Earth. And satellites can be natural, so the moon is natural, or it could be man-made, meaning it's artificial. On October 4th, and I mentioned this before, 1957, the Soviet Union launched Sputnik into orbit around the Earth. Okay, so we said that's the first artificial satellite. And artificial just means it's any human-made object placed in orbit around a body in space. Okay, that's why the moon is natural, because it's not human-made or man-made. A space probe, on the other hand, is an unmanned craft, meaning there's no human life in it. Okay, it doesn't have to have a driver. You want to look at it that way. It's unmanned and it's sent into space to do research. So when we want to get close-up pictures or information about the planets, moons, comets, and asteroids in our solar system, we can send out space probes. Okay, so that's the difference between the two. So let's look at the different types of satellites. So the four basic satellites that we have, and they can perform all sorts of functions. First one is the Earth sensing satellites. So the Earth sensing satellites, they're remote sensing. They are used to map and monitor Earth's resources. They can also provide valuable information on how Earth's surface is changing over time. So you can see here's a satellite that's been set out into space to do just that. The second one is a space sensing satellite. So we need the Earth's atmosphere to survive, but the atmosphere often is in the way when we try to study things in space. Okay, it sort of blocks it. So satellites are put in orbit above the Earth's atmosphere, and these satellites have a clear view of what scientists want to study in space. An example of that is the Hubble telescope. So the Hubble telescope orbits the Earth and is positioned above the atmosphere. So it can take pictures in space, and then it can send them to Earth so we can see the universe. Okay, the third one is what's known as a communication satellite. So radio waves cannot travel through the ground, and the curvature of the Earth gets in the way of radio signals that are sent far across the planet. So instead, radio signals are sent to satellites in space. What then happens is that The satellites, in turn, they will send the signal to another place on Earth. In fact, sometimes a satellite sends a message onto another satellite, which then sends it to the ground. So that means that messages can be sent all the way around the world this way. Look at all the different communication satellite. There's a Intelsat. Here's one for the remote sensing. It's called Landsat. For scientific research, there's Sampex, SOHO. When you're using your cellular or your mobile phone, okay, you have different satellites to allow you to communicate with people around the world. Echo 1, for example, is the first passive reflector communication satellite that was launched August 12th, 1960 by United States of America. And then navigation satellites. So you have ships, you have planes, you even have cars, can pinpoint their location on Earth by listening to the signal sent by several navigation satellites. As of 2023, there are 4 global systems that are operational. We got the United States Global Positioning System, GPS, and Russia's Global Navigation Satellite. You might be familiar with this, Navstar. This was a satellite-based navigation system that can be used by anyone with an appropriate receiver to pinpoint his or her location on Earth. Okay, space probes. So the space probes, we said, is an unmanned craft, and it's sent into space to do research. Here's a note about space probes. It is an uncrewed vehicle that carries scientific instruments to distant objects in space. Okay, we can't depend on just humans traveling to other planets, and other planets they can't get to, so humans cannot travel to other planets because of the harshness of space and the long distance. Using an uncrewed spacecraft, that means not having any humans in it, is one way to explore remote places. How many space probes are in space right now? Approximately 15 missions are currently operational. So space probes can come in all shapes and sizes, and as I've said, it can perform different functions. Most of them have cameras or have some type to take pictures of the objects they are studying. And because space probes can get closer to the objects they are studying, they can take much better pictures than we can from Earth. We had Voyager 1 and Voyager 2 were the 2 space probes that were launched in 1977, and they flew by Jupiter, Saturn, Uranus, and Neptune. Both of these probes are still operational. Some space probes are designed to land on other planets. We had Viking 1 and Viking 2. These were 2 probes that landed on Mars in 1976. 2 Mars exploration rovers, Spirit and Opportunity, were launched in 2003 and landed on Mars in 2004. So you can see how long it takes for it to get there to explore its surface and geology. It also searched for clues to past water activity on Mars. Scientists lost contact with Spirit on March 2010, but Opportunity has lasted for more than 12 years on Mars, although the rovers were intended to last only 3 months. There was also Mars 2020 rover, and also Perseverance was another space probe. And what they did was they looked for signs of ancient life, and they collected samples of rock and broken rock and soil for possible return to Earth. Okay, so what we have here is a brief history of space flight. So you can see that on page 39, beginning with October 4th, where the Soviet Union launched the first satellite into space in 1957. November 3rd, 1957, Soviet spacecraft Sputnik 2, they launched a spacecraft with a dog named Leica on board. However, the dog did not survive the voyage. Then, August 19th, 1960, Sputnik 5 was launched carrying the dogs Strelka and Belka. Now, they became the first living beings to survive a trip into space. April 12th, 1961, Russian cosmonaut Yuri Gagarin became the first human in space. Then in 1969, Neil Armstrong and Buzz Aldrin became the first men on the moon. So it goes on to, I have April 2001, Canadarm2, a robotic system for performing maintenance and assembly on the International Space Station. That was launched then. Then 2013 of May, we had Chris Hadfield, who's a Canadian, commander of Expedition 35 aboard the International Space Station. He filmed a YouTube music video of David Bowie's song Space Oddity. So that was the first music video ever filmed in space. Okay, let's do key question 21. So key question 21 says identify and describe 4 different types of artificial satellites. So basically you're naming each artificial satellite and then you are describing what they are. So if you remember, the first one is Earth sensing satellite. So I don't want a lot, just enough to describe what they do. So Earth sensing. The second one is space sensing. Okay, and so on. So just a brief description of each type of artificial satellite. Okay, human space exploration. So we talked about why do we explore space, and we said that human beings have always been interested or curious about what's around us, so it drives us to explore and discover new things. In addition, human space exploration also helps to answer fundamental questions about our place in the universe and also the history of our solar system. So if we look at the challenges that's related to human space exploration, then we can expand technology and carry out experiments that will teach us about many areas of science. So even though probes and satellites can tell us many useful things, having people travel to new locations in space can teach us more about ourselves. So in your book you can see 2 pictures, on the slide. You can see on the left, okay, there's a picture of a space shuttle, and then on the right hand side you can see that there's a picture of what's known as a rocket ship. Okay, so what's the difference? So a space shuttle is a reusable space vehicle. Okay, that means you can use it again, so reusable. Until the shuttle, no part of a space launch that blasted off was reused. Okay, so the rocket ship, okay, was non-reusable. Once it was sent off into space, then that was it. You can't reuse it anymore. With the space shuttle, some parts fell into the ocean, some parts will fall into the ocean, others will burn up while returning to Earth. With this rocket ship, even the capsules that carried the astronauts were not reused. So this approach to space exploration was too expensive, and scientists knew this, so they wanted a cheaper way to send things into space, and that's why they developed the space shuttle. So turn to page 40. So let's look at the space shuttle closely. So again, this is a reusable space vehicle. It has, or is designed to be used over and over again. Only one part of it, its main fuel tank, must be replaced. So let's look at the different parts of the space shuttle. Okay, number one is the shuttle or orbiter itself with its 3 main engines. Okay, so there's number one. So it's called the orbiter. So after mission lands, it lands like a glider. Okay, it has 3 main engines. We also see the 2 solid rocket boosters. That's for extra thrust. So these are the boosters, one on the left and one on the right. So it provides most of the lift for the first 2 minutes. It parachutes into the ocean after use. Booster is 2 feet shorter than the Statue of Liberty. So the height of the Statue of Liberty depends on how it is measured. So the statue itself is 151 feet tall, or if you want to convert it to meters, it's 46 meters. It's measured from the base of the statue to the torch. However, the foundation and pedestal are included. So if you look at it that way, then the statue has a height of 305 feet or 92 meters. So if you compare that with the rocket or the space shuttle, you can imagine how big it is. There's also the external tank. Okay, it holds fuel for the main engines, so that's the only part that isn't reused, so it burns up in the atmosphere after each launch. Okay, so let's look at the process for traveling or looking at the flight sequence for the space shuttle. So you can follow along. So pre-launch, you can see it's getting ready here. So that's before actually launching it. Then at blast off, all parts are connected. The main engines and the boosters both burn with a deafening roar. The shuttle lifts off and heads towards space. So you can see it now that it's so pre-launch, then it's launching. So you notice that after a few minutes, the boosters have used up their fuel. They separate and parachute back to Earth. They are recovered and reused. So don't forget the main tank is the one that's still attached and continues to feed the main engines. Then the external tank separates. This happens when it reaches its proper speed and position. So that's when you have the main fuel tank breaking away. It burns up as it plunges back through the atmosphere. Again, this is the only part that is not reused. So once that part is completed, the shuttle is now in orbit around the Earth. It may continue in orbit for several days, and then while in orbit, that's when the crew carries out what they're supposed to be doing. Okay, the mission, with the mission completed, the shuttle returns to Earth. Since it has no fuel, what happens to it is it glides back to Earth. The shuttle lands on wheels like an airplane. It is then made ready to be reused again. Okay, so that's the sequence of the space shuttle. So the space shuttle program, in total 5 shuttles were built and used for 135 missions from 1981 to 2011. They were launched from the Kennedy Space Center in Florida. Astronauts carried out various missions and experiments, including constructing and servicing the International Space Station, okay, or ISS. 2 shuttles were lost in accidents. Challenger in 1986 and Columbia in 2003, with a total of 14 astronauts killed. The space shuttle was retired from service upon the conclusion of Atlantis' final flight, and that was on July 21st, 2011. Until the Orion spacecraft is developed, crews travel to the International Space Station aboard the Russian Soyuz spacecraft. So the International Space Station is a space station or a habitable artificial satellite, and again is in orbit around Earth. It is the largest artificial satellite in orbit and can often be seen with the naked eye from Earth. So remember, naked eye just means you don't need anything special to see it. You don't need a special telescope. You could see it with the naked eye. It is made of pressurized modules, solar arrays, and many other components. Astronauts and space tourists from 17 different countries have visited the space station. Astronauts that are on board the ISS, they use it as a research laboratory. They can do experiments in biology, human biology, physics, astronomy, and many other disciplines. So as they use it, they can learn new ways to make sure that astronauts are safe, healthy, and productive while exploring. And we can also expand our knowledge about how objects and organisms behave outside of the influence of gravity. Okay, so you can see a picture here taken from that space station. So you can see a picture of it here. It says here is a small slice of the north side between the clouds. So you can see that. That's how they use that. Notice how clear the pictures are from there. Okay, we're going to stop here, but what I want you to do is, before we go, you can look at key question 22, which is in 2 or 3 sentences. You're just describing the International Space Station. So you can say the International Space Station, or I'm just going to put down the ISS, is a, we said it was a space station or a habitable. That means you can live there. Okay, space station. So that's one sentence. So do 2 more to add to that. Okay, we're going to stop here. So on Monday, we will continue with how do humans survive in space. So that is on page 43. So that's our last section. And then we will finish up with our key questions 23 to 26. Okay, and that would be the end of lesson 1. Okay, so thank you for joining me, and I will talk to you again on Monday. Miigwech.